Hi, I'm Patrick Vallely, and I'm a graduate student in the astronomy department at The Ohio State University. I'm also a member of the All-Sky Automated Survey for Supernovae, or ASASS-SN. Today I'm going to be talking briefly about some of the findings presented in my recent paper, The Highly Luminous Type 1bn Supernova ASASSN-14ms. ASASS-SN uses quadruple 14-centimeter telescopes deployed in Hawaii, Chile, and Texas to scan the entire sky down to roughly 17th magnitude every night in order to detect supernovae and other astronomical transients. The transient source that would eventually be named ASASSN-14ms was detected by Brutus, the ASASS-SN Hawaii unit, on December 26, 2014, offset by about 1.4 arcseconds from its host galaxy. We now know that this host is a fairly low metallicity galaxy located at a redshift of 0.054, which corresponds to a distance of about 240 megaparsecs. Spectroscopic follow-up indicated that the transient had prominent narrow helium emission features and only weak H-alpha signatures and no other hydrogen emission, leading to its classification as a Type 1bn supernovae. These supernovae are relatively rare, with only around 30 known, and they are assumed to be the result of stars exploding in environments with a dense, helium-rich circumstellar medium. They are closely related to more common Type 2n supernova, which are assumed to be the result of stars exploding in a dense, hydrogen-rich circumstellar environment. Broadly speaking, Type 1bn spectra closely resemble those of more typical Type 1bc spectra, with the addition of the narrow helium emission features mentioned before. Over the course of approximately 5 weeks, we obtained 6 spectra of ASASSN-14ms. Helium emission features can be easily seen in all spectra, and we also identify a variety of other elements, including calcium-2, oxygen-1, and magnesium-2. All 3 of these elements were identified in the archetypal Type 1bn supernova 2006 JC, so their identification here is not particularly surprising. In fact, from a spectroscopic standpoint, ASASSN-14ms is a fairly typical Type 1bn, as illustrated here in this plot, which compares a number of Type 1bn events at a comparable phase about 40 days after maximum light was attained. What makes ASASSN-14ms such an interesting object is its light curve. At a peak absolute V-band magnitude of greater than -20.5 and a peak bolometric luminosity greater than 10 to the 44 ergs per second, ASASSN-14ms is consistent with being the most luminous Type 1bn supernova yet discovered. Its bolometric light curve is shown here in red, compared to a sample of other Type 1bn supernovae for which there are publicly available bolometric light curves. The ASASSN-14ms light curve is both broader and considerably more luminous, remaining 5 to 10 times more luminous than a typical Type 1bn out to around 70 days beyond maximum light. In order to help explain this unusual light curve, we examined 3 simple physically motivated models. A model powered purely by the radioactive decay of nickel-56, a model powered solely by the energy deposition of a magnetar, and a model powered at early times by the interaction of supernova ejecta with the surrounding CSM, and at late times by the radioactive decay of nickel-56 products. We rule out the pure radioactive decay model immediately, because it is both a poor fit and requires the production of an unphysically large amount of nickel. But the magnetar and CSM interaction models both fit quite well with physically viable parameters. Since it is very difficult to observationally confirm the presence of a magnetar, and because we have compelling spectroscopic evidence for CSM interaction via the narrow helium emission features, we conclude that this is the most likely power source. This spectroscopic evidence for CSM interaction and the quality of the resulting model fit means that we don't need to invoke the kind of exotic energy deposition sources often necessary to explain other highly luminous supernovae. For more information on our observations and on our modeling efforts, please see our paper, which is posted on the archive, and thanks for watching.